Good day everyone, we are now here to discuss about the arithmetic sequences and series. This is lesson 11.2. So in this video, we will define an arithmetic sequence, give an example, and then we will try to define a formula or derive a formula for determining the nth term of an arithmetic sequence. Okay, so let's start. So an arithmetic sequence is a sequence of numbers where each successive number is the sum of the previous number and constant d. So let's take a look at an example to make this a lot clearer. Let's say we have here 1, 3, 5, 7, and 9. So 3 minus 1, that is 2, right? 5 minus 3, that is 2. 7 minus 5, that's 2. 9 minus 7, that's 2. Okay, so this is an arithmetic sequence because we have here a constant added to each term to get the next term. Okay, that's basically it. Okay, so if we convert this pattern into a general term, we get this one right here. So an is equal to n minus 1 plus d. Okay, so let's try to generate it. Generate our pattern right here. So if we try to write the specific general term for our example, we will have an is equal to an minus 1 plus 2, right? Because our constant difference here, or our constant difference is d, 2, right? Our d is 2. Okay, so let's try to generate from a1. Okay, so let's just practice. So a1 we know is 1, right? So a2, if we follow this pattern, we will get a1 plus 2. So what will we get? That will be 1 plus 2 should be equal to 3. Okay, so the next one, a3, that is a2 plus 2, which will be a2 is 3, and then plus 2, we get 5. Next one, 4. That will be a3 plus 2, and then this will be 5 plus 2, which is equal to 7. Now for our last term in our example, we will have a4 plus 2, which is equal to, we have 7 plus 2, which is equal to 9. Okay, so take note that the numbers that I will encircle, this one, this one, this one, all come from this one right here, n minus 1. Okay. Okay, so now that we know how to generate, so this can go on to infinity, right? Go on to infinity. Now, a problem now arises. Let's say we want to generate or to determine the 50th or let's say the 57th term of a particular arithmetic series, arithmetic sequence. Okay, so we can just add up to how many, say 57 times the d, right? So you can just add it again and again. But it is also more efficient if you have a formula for that. Okay, so let's try in this next part. Let's try if we can derive a formula to instantly get the nth term of an arithmetic sequence. Okay, so we start with a1. Let's start with a2. Okay, so a2, we know that a2 is equal to a1 plus d, right? Right, so let's not. Okay, we know that a2 is equal to a1 plus d. How about a3? a3 is equal to a2 plus d, right? a2 plus d, but a2 is equal to a1 plus d, right? And then plus d again. So a2 is equal to a1 plus d, so we have it right here, and then we have add another d, right? Okay, so let's say we want to find a4. a4 is a3 plus d. So what is a3? So we actually have to simplify it. So let's move it a bit. Okay, let's move it a bit to the left because we're running out of space here. Okay, So this is equal to A1 plus 2D, right? Okay, so we know that A3 is equal to, our A3 is equal to A1 plus 2D. Okay, so we can also write it as, sorry for that, A1 plus 2D plus D. So what will we get? If we add this D and 2D, the like terms, we will get again A1 plus 3D. Okay, so let's say we want to find A5 again. So this is A4 plus D. And what is our A4? Our A4 is A1 plus 3D. Okay, so you'll get A1 plus 3D plus D again. So you will then get A1 plus 4D. So as you can see here, we have a pattern. We have a noticeable pattern where we are adding A1 to a multiple of D. Now, what is in order to determine our formula here, we just need to determine the relationship between this multiple and our number here, the indicator. So the term indicator here, 3. So as you can see here, this is 2 is 3 minus 1, right? And then 3 here, 4 minus 1. 4 here is 5 minus 1. So we can then arrive at the general formula, which is AN is equal to A1 plus AN minus 1. Okay? I mean not AN minus 1, but N minus 1, because this is a multiple. So this is N minus 1 multiplied by D. Okay, so this is actually really cool. Okay, so we do not have to add over and over a certain D in order to get, let's say, 100th term. Okay, so let's try this out. Let's go back to our original pattern, original example. Say we have 1, 3, 5, 7, 9, 11, 13, 15, 17. Now, this is our A1, A2, A3, A4, A5, A6, A7, A8, A9. Okay, let's say that you were only given these numbers here, like we were given in example 1, and then we were asked to determine what is A9. Okay, what is the ninth term of this sequence? Okay, so we can then use our formula. Say A9 is equal to A1. What is A1? 1, right? And then plus N minus 1. We have 9 is our N. So we have here 9 minus 1 times D. What is our D? We know that our D is 2, right? The common difference. So that is 2. So if we calculate it, A9, calculate it. A9 is equal to 1 plus 8 times 2, which is equal to 17 indeed. So we have right here. Okay? So you can calculate up to 1,000. So whatever N term you want. Okay, so thank you for watching this video, and I hope you learned something, and I will see you in the next video.